Hello, welcome back to another video for the Math 201 Statistics Final Exam Review. This video will have a few problems on it, starting with question number 9. It says, a shoe manufacturer claims that athletes can increase their vertical jump heights using the manufacturer's new strength shoes. The vertical jump heights of 8 randomly selected athletes are measured. After the athletes have used the strength shoes for 8 months, their vertical jump heights are measured again. Find the differences of the after minus before. Okay. So for one, I took notice of increase. So that's telling me something. So we think that the after will be bigger than the before. So this will be 2, 3, 0, 1, -2, 2, 5, and 3. Letter A says, explain why the two samples are dependent. And that's because it's one sample measured twice. These 8 athletes were measured before they were using the strength shoes, and then they were measured again on their vertical jump after they had used them for 8 months. So at alpha equal to 0.10, is there enough evidence to support the manufacturer's claim? And we're assuming that they're normally distributed, and we're going to use the classical method. I'm going to also show the p-value method. So step 1 is, and because these are one sample measured twice, the simple that we're using is the mean of the differences is equal to 0. And then they want to claim, they're claiming that the mean differences are greater than 0, that they've improved. The alpha we're using is 0 equals 0.10. And because this is differences in means, we're using a t. So our test statistic is a t0. And that's equal to the average of the differences subtracting 0 divided by the standard deviation of the differences divided by the square root of n. And then our picture, because it's a greater than, it's a right-tailed test. And then this is our danger zone here. With the classical approach, we have a danger zone, right? But we can also use both methods, the danger zone and the p-value. So we'll need a critical t-value at alpha 0.10 and degrees of freedom, right? Because it's a t, so degrees of freedom is equal to n minus 1, and n minus 1 is 7. Okay, so I think we're all set up to go to Desmos here. So in Desmos, you'll see if you have that file open for the review, I put this data in tables, and then because it said we want to do the before, the after minus the before, that's going to be the y1 subtracting the x1s. So I took the mean of those differences and the standard deviation of those differences. And then we calculated the test statistic as 2.33. And then I also calculated our critical t-value as 1.4149. 1.415 is fine. So we can also go to the one sample means and put this in there and get the p-value. And right here, It's validating the test statistic that we calculated in our other Desmos screen. And we are looking at a greater than test. So I'm going to click on the greater than, and then there's my p-value, 0.026. So let's wrap it up on our paper. So the critical value being 1.415. So if we want to use the danger zone, we're going to mark our critical value. And so anything past there is in the danger zone. And ours, we are at 2.33. So this is us. This is the data. And so we're definitely in the danger zone. So we do reject H0. And we can also see that matches the redo reject H0 because our p-value is less than alpha, which is 0.110. So there is sufficient evidence to support the claim. Let's look at question number 10. Question 10 says, a real estate agent says that the average home sales prices in Dallas, Texas are different than those in Austin, Texas. He gathers a random sample from each location. He finds that the average price for 50 homes in Dallas was $247, $245, with a standard deviation of 2240, $470. Then he finds the average price of 50 homes in Austin, and there's the mean and standard deviation. It says, assuming that the two markets are independent, conduct a test at the agent's claim of 0.10 level significance. And I just don't have space here. I didn't write it, but we can look at our p-value and compare that to our alpha. Oops, 0.064. And we can see that our p-value is less than our alpha. And they want to see if they're different. And so we do reject H0. Okay. Question 11. It says, determine whether the sampling method is independent or dependent. Indicate whether the response variable is qualitative or quantitative. A says a researcher wants to know if the mean length of stay in for-profit hospitals is different from the mean length of stay in not-for-profit hospitals. He randomly selected 20 individuals in the for-profit hospital and matched them with 20 individuals in the not-for-profit hospital by diagnosis. Okay, so because they're matched by diagnosis, they're going to compare two things that are being matched up that are dependent. So they were chosen in one sample and chosen in the other sample based on their diagnosis. So this would be a dependent. And they are going to measure the length of stay. So that is a quantitative variable. And then B says, an urban economist believes that commute times to work in the South are less than commute times to work in the Midwest. He randomly selects 40 individuals in the South and 40 employed individuals in the Midwest and determines their commute times. So these are independent samples. One sample is not based on the other. They're not matched or paired up. So these are independent samples. And commute time is going to be something that's measured. So that's still quantitative. Okay, the last one for this video is going to be number 12. It's also, it looks like another matched pair, similar to question number 9. It says, assume that the paired differences come from a population that is normally distributed. We don't really have any story behind this one. It's just more of practice. It's asking us to take the differences of the x's minus the y's. So this would be 0.7 negative. And then this would be a positive 0.60, negative 0.1, negative 0.4, and negative 0.4. And so we're going to go to Desmos and put our data in and find the differences and the standard deviation. So we are testing that there's no difference, and they want us to test that of the a left-tailed test here. And so that means our test statistic is going to be a T0. And it's a left, so we're shading on the left here. And then we're going to go ahead and compare our p-value to the alpha of 0.05. So let's just head over to Desmos here. And there we are. So there's my data, and I'm taking the difference of x2 minus y2. And I've got the mean differences, a negative 0.1667. And the standard deviation is 0.4502. And I calculated our test statistic to be a negative 0.9032. And our critical T, if we wanted it, is equal to negative 2.015. So our test statistic is not further than our critical T. So we should not be rejecting H0, but we're going to go check it out in our means here. So we had 6 in our sample. The mean is a negative 0.1667. Standard deviation. And that's validating our test statistic, pretty close to what we calculated. I'm off by 3 thousandths, but that's okay because of rounding. And then this was a left-tailed test. And so it looks like our p-value is 0.203. The left-tailed, make sure you click on that drop down. And you can see our p-value is greater than alpha, so we do not reject H0. So there is not sufficient evidence. And Then it says compute a confidence interval, a 98% confidence interval. It says by hand, but we're just gonna go ahead and go back to the program that we were using and do the drop down for the confidence, but make sure our alpha is 1 minus 0.98, so alpha is 0.02. So alpha divided by 2 is 0.01. So we need to change the alpha because that does make a difference for the confidence interval in Desmos here. And so we click on that drop down. And so we're 98% confident that the true difference is between a negative 0.908 and 0.574. And letter E says, does the interval imply a significant difference in the two groups? So if there were no difference, like H0 says, then 0 will be inside the confidence interval, and 0 is inside the confidence interval. So there's not sufficient evidence. We don't reject. So it agrees with what we said in the hypothesis test. The confidence interval should agree with that. There is not significant difference. So that is all for this video through number 12 here. Text me back for the last two questions for 13 and 14.